wherever you are. My name is Arun Gupta. I am the VP and General Manager for Open Ecosystem Team at Intel. And if you want to learn about what my team does, you should go to open.intel.com, learn everything and anything that Intel and why and how we contribute to open source. And follow us at Open at Intel on Twitter. And we have a beautiful podcast as well. So we would love for you to take a look at that. Today, I'm super excited to talk about open source security. Woo! And I have two wonderful gentlemen with me, CRob and Dan. Hi, CRob and Dan.
Hey, Arun. Thanks for having me.
Hello. Thanks for inviting me as well.
Of course. Yeah, so open source security has been a very prominent topic over the last few years, at least the last couple of years, very prominently. So we hope to kind of dig into the details of it a little bit, understand from a user perspective. But before that, let's first of all start with some introductions. Go for it.
Dan?
Sure, I'll go first. My name is Dan Lorenc. I'm the co-founder and CEO at a startup called ChainGuard. Before that, I was at Google for close to a decade, where I worked in a bunch of open source security and open source security projects and efforts, like I helped get start the OpenSSF, the Salsa project, the SigStore project, and a bunch of the other projects inside of the OpenSSF today, like scorecards and a lot of other things that we're going to be talking about.
And those are the things we will be talking, as you said, deeply in the next hour or so. So hang in there. Don't get overwhelmed that what is the terminology Dan is throwing at us. All right, Krug.
All right. Hello, everybody. My name is Chris Robinson, aka CRob. I have been doing upstream open source security for over a decade. The biggest chunk of that was with Red Hat Product Security, where I was their program architect. And now, more recently, I've been here at Intel. I've been in the industry with Fortune 500 companies for nearly 30 years. And so I've had a lot of experience with operations, engineering, architecture, and security within very large enterprises. Uh, my current duties include working with a foundation called the Open Source Security Foundation, where my friends Arun and Dan are participants. I'm currently the chairperson for the Technical Advisory Council, where we help provide technical leadership and guidance to the community. But I also help facilitate a couple working groups around open source developer best practices, vulnerability disclosures. I participate with our end users working group, which is focused on downstream enterprise consumers of open source. And I participate in a lot of the efforts, like Dan mentioned, Salsa and Scorecard. A lot of these projects, Alpha and Omega, are all things I help support and participate in.
Awesome. Fantastic. I'm really looking forward to learning a lot about these, even though I have a little bit of a knowledge about them, but
Me too.
that's for the audience.
I
Well,
just used your name this morning to settle an argument, Crobe. We were debating how to pronounce the compiler that is part of the LLVM project, if you're familiar with that.
Yeah,
CLANG. You're Crobe instead of CRob, so I think that
I,
is Clang instead of CLang. But
I agree. I always call it Clang.
that's funny. Yeah. So maybe let's dig into the topic first. So, what is software supply chain security and why is it important?
Well, you're big right now, Dan. Why don't you start?
Sure. Software supply chains themselves are the act of getting software from a developer's keyboard to production or to end users or wherever that software is going to go. There's a whole bunch of steps involved in that. It looks like one of those duct tape and chicken wire Rube Goldberg machines inside of most organizations. And then once you factor in open source, it starts crossing organizations. So there's tons and tons of developers using tons and tons of tools on tons and tons of machines to get software from their laptops to package managers down into other build systems, into other intermediate formats, and then finally into something that you actually get to use and build as part of your product and ship to your end users.
Mhm.
The security aspect of that is when you start looking at that and get terrified. All of those steps, every single link in that chain has a lot of things that could go wrong. There are bad people on the internet. Those bad people do malicious things to software supply chains. There are also unintentional issues that happen in software supply chains, like everyday bugs or security vulnerabilities. It's a very large, messy smeared problem across organizations, companies, countries, the world. So that's what makes it challenging today.
And when I think about supply chain, software supply chains, and in particular open source software supply chains, I think of it within the lens of a software development lifecycle, but implemented through like a DevSecOps process where you have this continual integration. There's always these moving parts moving from creation to distribution and utilization. And then, like why this is important, our friends at Sonatype put out a bunch of different reports, and I think one of their last series of reports cited that almost 90% of commercial software has major components that are created and supported through open source software. And then you look at the recent trend in our industry is we have upwards of a 600 to 750% increase in these open source software supply chain attacks, where people have realized there's a lot of value within the open source ecosystem. And it's also, unfortunately, can be a target rich environment to affect a substantial amount of consumers, people in the cloud, people leveraging mobile applications, edge things. So there's just a really target rich environment, and the supply chain touches essentially every person on the planet, and open source is a very big part of that.
Yeah, that 900% increase stat is pretty staggering. I like to joke that the only thing growing faster than that 900% stat is the amount of times people cite that stat. It's Software
Right.
supply chain attacks, particularly in open source, are growing a lot lately. Awareness is growing even faster, though, which is a good thing. This topic wasn't talked about at all 2 or 3 years
No,
ago.
no.
So it's great that we have organizations in place in the U.S. government and a lot of other things to help out that we're going to talk about a lot more later.
Beautiful. So I think, Dan, you said bad people on the internet, they do bad things. I get it, and that's sort of what we're trying to protect against. CRob, you talked about how it needs to be embedded into the SDLC. You also mentioned DevSecOps. So tell us more about that. People have heard the term DevOps. Now we are evolving to DevSecOps, which is becoming more prominent. Let's dig into that a little bit. What is DevSecOps?
Oh, DevSecOps is another buzzword kind of describing a process of combining development activities, operational activities, and security activities. It used to be a lot of traditional organizations would be stovepiped, where you'd be siloed into these organizations, and the developers would never talk to the server administrators, and the server administrators would never talk to the network people, and no one ever talked to the security group. And DevOps and then ultimately DevSecOps is a movement to try to help integrate these activities to increase the velocity of delivering code to the business and to the business's users. And it basically kind of it's a combined tiger team like aspect where you have those developers working hand in hand with the people that are configuring the infrastructure, and then also you have these security experts that sit alongside these folks to help provide security auditing and good practice and help manage the tools and reactions to things that happen like vulnerabilities.
Yeah, no, I think that's very important because security is such an inherent part of this entire thing. It cannot be an afterthought. And that's what we are saying basically that, hey, let's integrate this during your development, during your operation, during your infrastructure provisioning, everything essentially. And then that's sort of what becomes DevSecOps. So essentially, the way you would say dev and ops people are sitting together, you are just interjecting security in entire across the layer.
Yeah, and it's kind of a reaction. Shifting left is a very common phrase, moving tasks closer to the developer. But it's really a reaction to kind of the classic siloing and waterfall methodology where you had phased gates and you had to wait until the end of the train to have your security review. And then potentially that could impact the whole project and delay delivering and kind of push people back to square one and having to go through all these steps again. And DevSecOps is a continuous integration, continuous delivery methodology where you write code, it immediately gets checked in, and then actions are taken to scan and massage and produce it. And so it increases that speed to delivery.
Beautiful. Um, you mentioned 600 to 750% increase in the supply chain attacks. talk to us about what are the primary security risks and threats that can happen in software supply chain, particularly given it's open source. And you talked about sort of the target rich environment, because if you target one simple library and that open source library is used all across the board, it's really the blast radius of that impact is massive. So, talk to us what can potentially go wrong in these things.
What can't go wrong? Um, there's some of the groups that I work with, and I think Dan participates in, is trying to do a threat model of the open source ecosystem. There's a lot of people, whether it's supply chain folks or security researchers, that are kind of diving into this. And one of the groups I work with, I think they've documented 30 or more specific types of attacks that can be executed from the spectrum of a developer writing software all the way down to being software being implemented into an operational environment into production code. So there's a lot of things that could go wrong, and some of them are malfeasance, a bad actor uh, impersonating code and doing something like a typo squat, or dependency confusion where they're intentionally inserting bad software. But it's also potentially mistakes. Software is made by people, and people oftentimes are on a rushed deadline. They might not have adequate resources or tools to check things. So, and we sometimes make mistakes. So there's a whole spectrum of things that could go wrong, from just a oopsie, I fat fingered something on the keyboard, to you have a very bad person trying to insert ransomware or something into your supply chain.
Got it. Then you run a company, you founded a company, Chain Guard. So tell us about the company and then tell us from your customer's perspective, where do they see these things going wrong?
Sure. Yeah, CRob did a really good job breaking down the space. I like to kind of break it down into two main areas, and I'll kind of talk about how that really is into our company. One of them is like that kind of malicious bad people problem, right? Supply chains are long and messy and complicated, and when you point attackers at them, they can find lots of ways in. And so you might know what your supply chain is, but you probably don't have a lot of integrity there. The links are all pretty weak, and they can be tampered, and bad things happen that way with people stealing accounts or password compromises or takeovers of GitHub Actions and stuff like that. So that's the
Mhm.
integrity problem. The other one is the quality problem, right? And that's garbage in, garbage out is one way to think about it. So even if you have a really secure pipeline, if you put bad stuff in, bad stuff comes out on the other side. By all metrics, open source code is more secure than proprietary code, right? There's a lot of misnomers that happen that way, but all code has bugs. When you're a company starting off and 98% of the code is open source, then you're probably going to find 98% of the bugs in that stuff, assuming it's equal. And so there's a lot of bugs in open source code just because there are a lot of bugs in all software, and some of those bugs have security issues. So that's kind of how I break the overall space down, the kind of quality one and then that integrity one. They're very different problems, but they get lumped together into that category. So you asked about my company. My company, ChainGuard. We're a startup. We're about 2 years old. We're about 70 people today, somewhere around there. The space is all pretty new right now. I'd say we're more focused on that quality problem. So people use tons and tons and tons of open source code inside of their companies, and vulnerability management is a huge pain point. Open source code is really, really, really easy to use. It's free. You can just grab it from the internet, and so people do that. And so at large companies, you find thousands of open source packages all over the place that people haven't necessarily done a good job of keeping track of or maintaining or having asset management or inventory management databases. It's a little bit ironic when you look at it. If you want to onboard a new vendor at a company, you have to go get SOC 2 approvals and security questionnaires and all of that before you're allowed to use someone's code. But if it's just on the internet on GitHub, then developers are pretty much allowed to pull that in without going through any of that stuff. And so that's been a huge pain point for folks. And so that's where we're focused today. We have a big program to help proactively find security issues, patch them, inventory management for open source, and SLAs around a lot of that stuff.
Beautiful, beautiful. Thank you so much. Now, you mentioned and open source code is more secure than the proprietary one. And I was in a panel discussion, and we had a very heated discussion about that particular topic. And I come from a strong open source camp. So I would love to hear you qualify that statement a bit more.
Sure, and it does have to be qualified. I often skip over it sometimes and then get called out, but I think it's obvious in many ways when you look at all the metrics and stats. Open source code is the majority of code out there, but when you look at, say, the CISA, a U.S. agency that tracks vulnerabilities, they have a database called the Known Exploited Vulnerabilities Database, the
Mhm.
KEV, it's called, or something like that, where they take vulnerabilities that are found, and as soon as there's active intelligence about exploits, they publish it there, and you can go look at that feed daily. 90% of those vulnerabilities are in proprietary software, even though 90% of the software being used being open source, right? You can pull out metrics like that over and over again just to show this effect. Um, Open source is everywhere, it's around. Some folks kind of get worried and scared that when we talk about open source security, that might imply that open source is inherently insecure, and that's going to lead to some fear or rush away from using open source. I'm hoping that we're beyond that point today, right? This isn't the 90s. There's no FUD campaigns against open source and scare tactics against using certain licensed software. Licensing in open source is another huge issue right now, but we'll stay away from that one for today. But I do hope that we can qualify this. The stats are out there. Let's just get a page up to point people to, and then resume discussing how to make it even more secure instead of having to continually defend the security of open source.
That's a beautiful statistics, in the sense that 90% of the vulnerabilities are from closed source software, even when 90% of the software is open source that is used in there. That just magnifies the volume significantly. And again, I go back to Linus's law that, given enough eyeballs, all bugs are shallow. And the diversity and the inclusion aspect of it, that's, hackers around the world are looking at it. You can never get that collective wisdom of engineering community to be able to tap into it.
And the wonderful thing about Linus's law is that open source code, per the licensing, is 100% open and transparent, and people are invited to look at it. So anyone that's interested, if there's a piece of software that you use as part of your enterprise or offering you provide, you're allowed to look at that. You can scan that. You can provide the development team feedback. You can submit patches if you find things that are wrong. And this activity happens daily throughout the ecosystem, where you have, whether it's a project member or a concerned user, well, they'll actually do some of these activities and provide that feedback to the project and make it better.
Got it. Beautiful. Now, we talked about vulnerabilities. Software has to be updated, patches have to be done. So how are organizations today effectively managing all of that, vulnerabilities, patches across the supply chain? And also talk in terms of that vulnerability database that you talked about. So talk about that concept a little bit.
Well, I guess I'll start. Part of my background is I worked for about 7 years at a super regional bank. So we were heavily regulated. So we got to talk to the nice people from the U.S. government and the Treasury all the time. Was a lot of fun. And to that end, there's a lot of requirements, especially in regulated industries, whether it's energy, banking, healthcare. And I think these regulations typically tend to help provide some good practice. But one of the expectations inside regulated environments is, as vulnerabilities are identified, there's a certain cadence with which you need to respond to those based on their severity or whatever criteria or your part of your risk management program. And so a lot of companies will rely upon security scanners or these external databases. There's the most widely cited one is the National Vulnerability Database, but there are many others. There's a database in China. There's going to be a database forming in the EU. We have an open source alternative called GSD and OSV. So there's a lot of ways you can learn about this information. But basically, as an enterprise gets that intelligence that there's updates, it's a vulnerability management team's responsibility to go in, triage those, understand where those vulnerabilities might live within that enterprise, and then issue orders like thou you need to get this updated within X amount of time frame. If it's a PCI system dealing with cardholder data, that has to be done more quickly. But if it's something, it's a back end, it's the cafeteria lunch menu system, you might have 60 or 90 days potentially to patch a vulnerability based off of severity. So generally, most enterprises, most large companies will have a program to monitor the applicable patches and vulnerabilities that need deployed, and they'll have some criteria with which they'll kind of push the speed with which those are pushed out.
And how are those vulnerabilities? And we'll talk about Log4j a little bit later. But how are those vulnerabilities disclosed in an open source project and announced and then percolated down the supply chain?
A lot of different ways, depending on kind of the age and maturity of the open source software. So if you're more of coming from a Linux based space, those groups tend to be very instantiated in things like mailing lists. Or so as vulnerabilities are disclosed, they'll post to their mailing list or post to a blog or a forum. As you get into some of the newer development languages, they might do all their work exclusively inside of a source repository like GitHub, and they might leverage automated features like GitHub security advisories. Um, so it really depends. But at the end of the day, when a CVE gets issued, that will go through the CVE program and will ultimately get published as part of that program, and then make it into a database like the NVD that are monitoring that, and they'll pull that in and advertise it. And then organizations like the CISA Kev service, as they notice things that are being exploited, they'll do additional advisory and notifications. And
And
that's,
that's where the
upstream has a lot of different variation in how
yeah,
they notify their downstream.
and that's where the vendor company is going to come in. They look at the NVD. They say, "Oh, I'm going to update my tool and bring it in." So, Dan, give me that perspective from the commercial company. How does that work?
Not well. There's a lot of problems involved, kind
Aw.
of at every stage here. Um, yeah, when it's working well, there's a lot of stuff involved, and there's a lot of things that can go wrong here with it. We're seeing a bunch of issues with this just today and this week alone, with kind of bad data being entered, bad
Mhm.
queries, tools kind of picking up on stuff and adding to a lot of noise. But I think in general, if you ask people how well this works, you get a bunch of swear words probably, and then once you calm people down, some kind of discussion around a lot of false positives and a lot of noise. The signal to noise ratio is not very good through this whole pipeline, and there's a bunch of reasons for it, but I think none of them are insurmountable. So I think we are trending in the right direction, hopefully. Some of the issues that we're seeing lately are around a whole bunch of extra things getting filed due to bad incentives. CVs used to be this big badge. Like if you found one in a piece of software, you could be proud of it. People would put it on their resumes. Like I found this one, and it was a cool thing for hackers and vulnerability researchers if you'd found a CVE. Software scaled up, so they had to scale the systems for filing CVEs, to the point now where there are people in bug bounty programs and stuff just going and finding bad data and kind of DOSing in some ways the whole process just to get entries to put on their resume or to win bug bounties, which are easy for them to do. It's a little bit of work for the database to filter stuff on the way in, but it's a huge downstream impact for those regulated industries like CRob talked about, that don't get to just ignore stuff because they think it's bad. They have to look at every single one and take an action and file a long plan, because there was this large amount of implicit trust in the database that's kind of been eroded over time. There's this other kind of phenomenon where tools are getting better at finding things. We're getting better at inventory management. We're getting better at scanning packages to find what open source dependencies are inside. There's a friend of mine, Phil Venables. He's a CISO at banks, and he works at Google now in the security group. He has this great blog post called "The Uncanny Valley of Security," which is where if you
Yeah.
have this scanner that doesn't really work that well, and you run it and you find one or two vulnerabilities a week and you get through them, you're happy, and then you find it and buy a better scanner. Now there's 100 vulnerabilities a week. It seems like like everything's on fire now and you're underwater. You're not any worse off. You just know about more things. And so as technology is improving on that side too, we have more vulnerabilities coming into the system. We're getting better at finding them, getting better at detecting things. Stuff that used to be handleable by a small team of one or two folks is now, takes massive teams at organizations, just because there's more software and the tooling for noticing things is better.
Mhm.
Wonderful.
And then one other thing to consider with open source, typically when you find a bug, you fix it and immediately push things out. And most upstream communities support like N-1 versions of their software, so they don't do long life support. And when you're thinking about a traditional enterprise, you might have a system in place for 3, 5, 10 years, which is much longer than how upstream might support things. So as an enterprise, you might have dozens to hundreds of different vendors. So you're getting thousands of vulnerability reports a month, and each one of those needs to be kind of reviewed because upstream is moving at a very fast pace and cadence, and they might break like ABI or API compatibility of your particular installation because that's not part of their scope of concern. And you need to go through and do some pretty rigorous testing before you deploy all these patches. So it's a not inconsequential amount of work having
Yeah,
a vulnerability management program.
of
Yeah,
course.
there's a burden on open source maintainers too. While we're on this, we could just rant about this for the next half hour. But we should probably cut it pretty soon. But it's a huge burden on open source maintainers too. Daniel Stenberg, the maintainer of the curl project, curl is used for accessing the internet and pretty much every device application in the world. The library is there. He does an amazing job at triaging and patching security vulnerabilities in curl as they're found. But he doesn't actually get a say in vulnerabilities in the NVD for curl. Anyone can file a vulnerability against any piece of software. It's this global rights system that is set up that way for good reason. Vendors have bad incentives and all of this fun stuff. But just this week, he had a long blog post rant about somebody went and got a CVE ID assigned for something fixed like 4 years ago in curl that is not a security vulnerability by any means. Somebody just found it there and tried to get one for bonus points on their LinkedIn resume or something. And the NVD scored it as a 9.8 out of 10 as well. So it had already been found and fixed years ago, wasn't running in any systems, and somebody did this just to create a bunch of noise and get a little badge for themselves.
Yeah.
The math on how you get a 9.8 out of 10 is I don't know what calculus someone used to come up with that one. Log4j itself was that score, right? Like, and this is not even a security issue or a bug, and we're seeing this across programs all the time. So maintainers are getting stuck at the with the short end of the stick here because all those vendors, yeah, it's a lot of work for them, but at the end of the day, they just go and complain to these maintainers for patches.
Beautiful. Let's pivot a little bit. What is the concept of software bill of materials, and how does that help with this vulnerability management aspect?
Is Alan showing up?
We're
You say
20,
SCOM, Alan shows up.
we're 27 minutes in. That's a new record for a podcast on open source security without saying SBOM. I have a little running time.
There's probably a bell ringing in
Yeah.
Alan's office that, hey, somebody's saying the word S.
Yeah, a software bill of materials ties into all of this, and it's going to create
Mhm.
a bunch of problems, but also fix a bunch of problems at the same time. So it's really going to change the way software is delivered, maintained, and vulnerability management is done on it. A software bill of materials is exactly what it sounds like. It's a bill of materials for what goes into a piece of software. Software is comprised of tons of other software, tons of other libraries and packages and dependencies and tools. And if you buy, a piece of box or shrink wrap software, like you used to do when you go into CompUSA and pick something up by the checkout, you don't know what's in there. You don't know what's in there, and that's a problem for a lot of reasons. One of them, the main one, is that if you install that inside of your systems and say a security vulnerability is announced, you might not know that that was in one of the dependencies inside of your application, and you might not know that you're supposed to be taking action because of that. Now, vendors try their hardest to announce things, but just like at the CompUSA store, like you probably didn't fill out the little registration card and mail it to the vendor to tell them that you purchased the product. So they don't even have any way to notify you because they don't know you're running that version of that piece of software. This is really hairy in regulated environments where stuff is run inside of air gaps, and there's really no way for someone outside to know that that thing is in there, even though there could still be security issues. So this whole notion of an SBOM is that a vendor, when they sell you a piece of software like that, will attach a standardized piece of metadata that explains what's in there, so you can take action on your own to be able to at least notify teams, ask for fixes, apply remediations when something bad does happen. The downside is that that's a lot more information to feed into those scanners, and that uncanny valley is going to get even deeper. If you're used to scanning one piece of software and it's comprised of 10,000 subpackages, multiply that noise in that vulnerability management equation by 10,000, because now you're going to be scanning 10,000 different things. Until that forces the whole system to improve and get finer grained metadata and all of that, I think the noise problem is going to increase in the short term, but it's going to be so painful that I think we'll end up with a fix at the end.
Yeah, and I think well-intended regulators have talked about, software bill of materials is important and needs to be done before the standard has been solidified, and more importantly, before the tooling has been put into place to help uh, integrate and aggregate all of this information. Again, if you're an enterprise and you have 600 vendors, you're potentially going to have 600 or more S-bombs that you need to sift through when you get these vulnerability reports. And there aren't a lot of offerings, commercial or open source yet, that can do that and kind of merge everything and make it actionable information yet. It's just a giant wall of text.
And there's a federal mandate as well that was given a couple of years ago that, hey, if you want to interact with the federal government, then you must have a S-bomb. And I believe the date has already passed, the first date has already passed.
Yes.
So talk to me about that federal mandate.
Sure. Yeah, I can start on this one. The federal government, in the wake of the kind of first major supply chain breach, the supply chain attack on SolarWinds at the end of 2020, rolled out a whole bunch of new regulations and mandates to try to improve our nation's posture for cybersecurity and supply chain security. The executive order was titled EO 14028 from the Biden administration, something like that, and it covered a bunch of things. One of those things was kind of this SBOM mandate. You can't just sign an executive order that declares all software is secure. It doesn't quite work that way. So instead, it kicked off a long set of steps from other agencies and regulators to work with industry. And I know, CRob, you participated in a bunch of those working groups to explain what the best practices actually are, because these regulators are not necessarily the most up to date on computers or internet or cybersecurity. Or open source. So there's a lot of discussions with industry to figure out what makes sense, what doesn't make sense, and then how to start rolling this stuff out. So the phase we're at now, yeah, like you mentioned, is the federal government as a purchaser. They happen to be the largest consumer of software in the world by dollars. They buy the most software out of anyone, and so they're allowed to demand things from their vendors if their vendors want to keep selling stuff to them. And so that's one of the easiest ways the government can push regulations like this in the cybersecurity space. And so they're doing a bunch of things, not just SBOMs. Right? There's another long document called the SSDF, the Secure Software Development Framework, that is also being rolled out later this fall. But if you want to sell software to the government, you're going to have to start taking security a lot more seriously and then producing evidence to show that you did so. SBOM is just one type of that evidence.
And the SBOM idea may have started here in the States 3-4 years ago with the US's Department of Commerce NTIA group, but this has blossomed as an idea around the globe. You're going to see the European Union has a new Cyber Resiliency Act that will be going into effect this fall that also has some stipulations around SBOM and manifesting. And this is a idea shared in Asia and like all different parts of the globe. So you're going to see this isn't just a U.S. thing; it'll be international. And the one benefit to the process that Dan described of issuing this executive order and the U.S. federal government making these requirements is even if you don't supply or interact with the U.S. government, many vendors do, and it's a part of their business. So they're going to have to uplift the standards of their whole portfolio. So at the end, all consumers should benefit from some of these stricter standards once things get stabilized and standardized that we have actual actionable ways of executing on it.
Yeah,
And
the
this is
concept here is rising tide lift all boats here. So you're lifting the entire ecosystem. And to me, SBOM is like, I go to Costco, I pick up a cereal, what is the protein content? What is what are the macronutrients around it? But now I'm going a level deeper. Tell me, when you build this, yeah, exactly, yeah, when you build this nature's garden snack, tell me where it is coming from, where it is sourced from, all the way deep in, because so that I understand what the dependencies are. And if the farmer had some allergy to it, something, then I don't want to eat this product, because then I'm much more informed, because then it's upon me. Dan, you were trying to say something.
Yeah, and there's yeah, 2 points there. One, yeah, the SBOM is great. That food analogy is awesome, and it's awesome because it explains exactly what it can and what it can't do. Right?
Mhm.
If say you go to Chipotle and buy a burrito bowl and the lettuce gets recalled because it came from a farm or something like that, the ingredient list is just going to tell you that there was lettuce in there. Right? It doesn't actually contain the full provenance and exactly which farmer and which lot that everything was built in. And so it can cover parts of that, which isn't nothing. It is still valuable for kind of that situation where the entire component is found defective or you're allergic to it. That's good for that one. The other part that it can't quite do, which the rest of kind of these regulations do, is around tamper resilience, right? So in that SolarWinds example, when there was a backdoor placed into that binary that was distributed, I don't think anybody would have opened up an SBOM and seen, malware.dll line 372 or something like that,
Right.
right? The SBOM is only as good as the tooling that generates it, and it's only as good as the information that actually gets put in there. So it is good for that limited use case around, allergies and, just incompatibilities and everything. But the good part is that the strategy doesn't stop there, even though it does kind of dominate most of the conversations. The rest of the secure software development framework and the self-attestation requirements rolling out soon do cover kind of that whole broad spectrum of requirements to actually improve and make a difference in cybersecurity. And also, it's not just limited to people that sell to the federal government. That's where it's starting, but it's going to hit everyone pretty soon.
Mm-hmm.
There's requirements in there that apply recursively. So if you're a vendor that sells to the federal government, you're also going to have to require these same things from your vendors. Everyone is in this supply chain together. You might be a couple levels removed, but it's going to get there pretty soon too if you want to keep selling software to anyone that sells software to anyone that sells software to the US government. At some point, you've kind of taken over the whole industry. So the rising tide does lift all boats, and it actually has to because the supply chain risk applies transitively.
Mm-hmm.
If everyone does it except for someone, then we're all still vulnerable.
Beautiful.
Great point.
Uh, Crow, you started talking about the Cyber Resiliency Act, and the role of the federal government in all of this. Now, over the last few years, there is, of course, Cybersecurity and Infrastructure Safety Agency, CISA. There is a Cyber Safety Review Board. They have a they produce a report around Log4j. And so federal government does seem to play a very big role in all of this, kind of lifting that overall open source security posture. Break us down, like the role for CISA, CSRB, and all of this into this entire gamut.
Well, the U.S. federal government is very large and very complex, and these different groups, whether it's the CSRB or CISA or the ONCB, they are focused on different aspects of how the U.S. government supports this nation. Um, CISA has, I believe, been put overall in charge of cybersecurity, and they have taken over things like the CVE and the NVD program. So they're kind of the canary in the coal mine, so to speak, where they are helping coordinate a lot of this information and then passing it along to particular subject matter experts, whether it's in the civilian or military aspects of the U.S. government. And again, there are equivalent bodies around the globe. Like over in the European Union, you have a NISA, who is kind of a counterpart to CISA slash NIST, where they set the tone for cyber for the European Union. So there's a lot of these equivalent groups around the globe.
Beautiful. Got it. Okay. Yeah. I mean, the federal government does play a significant role. And as you said, I think Dan was saying they are the biggest consumer of software. And as the biggest consumer, you can actually say, you know what, this is what I want. You want to work with me? You want to sell me software? This is what I want, which is a good thing. And I'm really excited about that.
Mm-hmm.
There's a lot of work happening in OpenSSF. This is around open source security. So, and both of you are very active members in there. So, tell us what OpenSSF is about and their charter, as I understand. Well, I'm on the governing board. I should understand, as I know, is to raise the security posture of open source. So, tell us what it kind of break us apart. Like, how is OpenSSF structured? What are the fun things happening over there? What has been delivered? What's on the roadmap, kind of a thing?
Mm-hmm. I'll start in and feel free to fob in expert information along the way, Dan. As Arun mentioned, the foundation is focused on uplifting the security posture of open source software for all users and creators. We focus on a couple different personas or user types or use cases. So one of the primary constituents we're trying to serve are open source maintainers and developers. Another important constituent we're trying to serve is also the downstream open source software consumers. And this could be a commercial enterprise like an Intel or a Chain Guard, or it could be a bank or a retailer or a hospital or a power plant. And then there's other constituents we interact with, like the security research community, the other open source foundations. I love OpenSSF, but it's not the only open source foundation. There are things dedicated towards confidential computing or cloud native computing. So there's a lot of different efforts. So we're one of many voices trying to help uh, dive into certain aspects of the community. And the OpenSSF in particular, we have a good mixture of software projects, things like SigStore, which is a digital signing mechanism, and then we have things like the scorecard, which helps advertise security qualities of specific pieces of open source software. And then we have kind of standards, specifications, documentation projects. Like we have a whole group dedicated towards these source code management repositories, and they've put out a list of recommended best practices for these source code repositories. We also have a whole team dedicated towards helping get security training and information and tooling in the hands of open source developers. We have a whole group of folks working on coordinating vulnerability disclosure. How can we help make that more consistent, get projects access to tooling or subject matter experts to help improve their project? And a whole slew of other things. We have a whole group, and I know Dan participates in the supply chain integrity group with things like Salsa and S2C2F and Fresca and Guac. We have a lot of projects focused specifically on kind of the plumbing of the open source ecosystem and how consumers can react to that. What am I missing, Dan?
There's a lot going on, I think. And yeah, I think you covered what's going on today. Probably most of it, although I'm sure you missed some. I just add that yeah, it's been around for about 3 years now, which feels kind of crazy. It got started right before the pandemic. If you remember any of the history, we had this kickoff meeting in Austin, and it was when all these like headlines were on the news around how it was weird that people were using elbows to bump instead of high fiving or shaking hands because there was this like disease happening. And it got kicked off like right then. And I remember it was like the last meal I had with adults outside of my house for a very long time was that kickoff meeting. So it's been through a lot, and it's been through a lot of changes. But the pressures and the regulatory environment and everything made it just even more important.
Mhm. Well, and we also partner with researchers. So one of our projects is the Harvard Census, which is a group is trying to understand what the most used and most critical open source projects are, and that's kind of the playbook that a lot of the foundation is going to react on. Is these high profile, high impact projects? We're going to work with them to help see what those communities need in regards to security. Maybe they want assistance in getting set up as a CNA, which is a CVE naming authority, a group that gives out vulnerability identifiers. Or maybe they want help with a security audit, kind of going through a line by line code audit. Or maybe they want help understanding and kind of hardening their CI/CD infrastructure. There's a lot of different aspects and ways that the foundation's helping approach some of the most critical software on the planet.
Yeah, so thank you. Dan, you talked about, you were instrumental in launching Six Store, Salsa, and those kind of projects. Give us like a quick sync on what these projects are and how do they raise the security posture?
Sure. Yeah, I'll start with SigStore. SigStore is a tool for open source maintainers and anyone really to be able to sign and verify their code. So we talked about SBOMs being the ingredient list. Digital signatures are kind of like that tamper-proof seal. So when you buy,
Mhm.
some medicine and you crack it open and there's that tamper-proof seal on top, so you know it hasn't been tampered with or poisoned. That is the role that digital signatures play in all of our open source supply chains. So if a maintainer of a project commits and signs off to a release and they've verified it and reviewed it and you trust them and they publish it onto the internet and it gets mirrored and distributed a whole bunch of different places. Signatures are that tool that lets you make sure it actually came from that person and a bad person on the internet hasn't done something malicious with it in the middle. For open source, that's traditionally been very hard. Digital signatures have been around, but they had these kind of sketchy CAs where you had to upload like a business certificate and a fax machine and pay a bunch of money to get a certificate kind of mailed back to you. It felt like the early days of like browser certificates in the 90s and 2000s when that's how you got an HTTPS URL set up by buying one of these things. It was good for a couple years, and if you lost it, you had to go get a new one, and most websites just didn't bother with it. That's how digital signatures were in open source. And
Mhm.
so SigStore kind of copied the same playbook that Let's Encrypt did for browser TLS. Let's Encrypt automated all of it, made some new standards, and then operated it for free. And when they did that, instead of having to pay somebody with a fax machine, you could just add a little boolean to your config file, and it would go through this little let's encrypt dance, and you get a certificate. And it turns out developers don't like doing things insecurely. They just don't want to do extra steps at all because they're very lazy. When you make it that easy, TLS adoption.
Busy.
When you make it that easy, TLS adoption went from like 50% across the internet to like 99% in 3 short years because of that. And so the Sigstore project aims to do something very similar for open source code. You don't have to install or configure or generate private keys or go to those like key signing parties that used to be around. You just download this
I've
tool.
been there.
You can run a sign command, and you can sign your Git commits, packages, containers, anything you want. And so you can verify when you find it later if your organization is going to run it, verify that it actually came from the person who you intended to receive it from.
Beautiful, beautiful. And what about that's fantastic. I can see how it is simplifying. So we are kind of getting like a 20-year push, making it happen now. What about the Salsa project?
Sure. Yeah, the Salsa project, or SLSA, I can never remember what it stands for. Security levels for software artifacts, something like that. It's a set of steps, a set of levels, a set of requirements, a set of recommendations, kind of in this gradual way about how to operate your build systems and your build infrastructure in a secure manner. One of the other kind of things that has plagued supply chain security, both in open source and proprietary software, is that it's often neglected, right? You buy tons and
Mhm.
tons of fancy endpoint management and production security tools and all of that to make sure no one can have access to your production servers and infrastructure. But then in most organizations, you'll find that there's a Jenkins machine under someone's desk on a Mac Mini that's been deprecated for a couple years that actually does the builds and publishing things to production. And you find that to publish it to production, it probably has production keys sitting there on it and all sorts of other terrible things. And you're forgetting to patch it because you kind of forget it's even there. That is a huge security risk in the supply chain space. So the Salsa project has a set of levels that kind of make that problem tractable. So instead of being overwhelmed with all of the security things that you need to do, it says, level one, just do a couple basic things, and you're better than most people out there used to be, or most people out there are today. Level two, you start taking it more seriously, and there's recommendations for every step there. And so projects and companies can track this as OKRs across teams and make improvements. And there's fancy little badges on GitHub showing how seriously maintainers take things. And like the Kubernetes
Mhm.
project and a bunch of things in the CNCF now have requirements for projects to be at certain salsa levels when they release binaries.
Beautiful. It's like when I'm starting a marathon, when I take the first step, I can't be thinking about 26.2 miles. I got to think about, okay, let me cover the first mile and then the next mile and then the next mile. So you're really breaking it down, making it easy for people to understand and comprehend in a very clear, actionable manner. You want to improve the security posture? Here's what you do.
Do this first, right?
Yep.
Awesome. Krob, started talking about OpenSSF scorecards.
Did.
What is their relevance and what's the work happening over there in OpenSSF to improve the security posture?
Yeah, the scorecard is a pretty amazing project where they have collected a series of good or best practices or expected behaviors. We'd like to see these qualities within a software project. And it goes kind of hand in hand with another project called the OpenSSF Badges Project, which is a means with which a development team or a project can kind of attest to we do these expected security practices, like having multiple maintainers or having a process for committing code to production. So these expected behaviors. So a scorecard takes all these qualities and automates the checking, the intelligence on that, and then produces a report periodically. And it used to be exclusive to GitHub because that's what the development team knew best. And so there's several hundred. I think it actually goes up to, I can't recall the specific figure, but it's a very large number of projects are being automatically reviewed every week. And that score is published out to the internet. So, as a user of that software, maybe in my own project, maybe I'm going to use it as a dependency, or as a downstream, like enterprise consumer, I can look up the score and see precisely where things, what are they doing? And, do I like that? Do I want to make other choices, pick other packages, or do I maybe try to engage with that project to say, have you considered adding additional maintainers? Could I help be a maintainer or whatever contributor? And then the scorecard team just recently enabled that same functionality inside of the GitLab environment. And so we're looking to try to make these tools widely available to capture the most amount of software and just provide people that kind of third party perspective are, here's the expected standards and qualities we'd like to see in the software, and here's what we're able to observe. This is evidence we've collected and we understand these things are being done. So it really ideally helps uh, downstream making better choices as they're integrating software into their environments.
That's beautiful because essentially what we're doing is we're giving them simple, easy to use tools like a GitHub Action or in GitLab, wherever the developers are living, is run these tools, integrate them as part of your CI CD, get the right
Mhm.
scores out, and whatever your score is, this is not a judgment on the project, but think of it as a data. Once you look at the data, then that data gives you more insight that, oh, here are the things that you can change in your project to improve the overall score, and that becomes that much more relevant to the developers.
And that was kind of the gauntlet that Intel picked up, is we really liked the idea of the scorecard project. So we liked it so much we integrated all of our external GitHub repos into it. And there was a broad spectrum of scores from good to less good. And we've taken that kind of as an action item. We want to hit a certain threshold with the quality of our software. And we are working internally to try to, raise everything up to an acceptable level of quality.
Absolutely. And we are drawing that exercise. We just started that exercise. So basically getting that entire dashboard and looking into each and every project, why the score is low. And then we
Mhm.
again, we got to contribute back to the project itself. So any lessons, any learnings that we will make through this will contribute back to the project. Dan, you had a point as well on that?
Oh, I'm just saying this is awesome to see. I think I wrote the first version of the scorecards tool on like a Saturday afternoon and just made up a bunch of best practices that seemed easy to do with
Thank
the
you.
GitHub API. And now it's awesome to see people. I mean, the project has come a huge way since then, and I haven't been involved in years. But yeah, it's
Beautiful.
fun to see people actually
It's
roll
a
it
great
out and look
tool.
at the scores and make improvements based on it.
Well, I mean, open source stands on the shoulder of
Yeah.
giants, and we got two giants right here.
I'm the littlest giant.
Pivoting the topic a little bit, what about the point of memory safe languages? Are they more secure?
You say that like it's a trick question.
Uh,
I don't know. You tell me.
yes, memory safe languages are more secure than non memory safe languages, but they are not without their own failings and opportunities for vulnerabilities. And not every but you probably have heard that the Linux kernel team is integrating and migrating certain components to
Yeah,
Rust because of those memory safety
yeah,
qualities. And by doing that, by going to a memory safe language, you get to avoid kind of certain classes of issues if you're doing it correctly. So they're looking at, kind of reducing their workload. They're going to invest development time to convert certain components like drivers and whatnot, and then that ideally saves them time down the road handling vulnerabilities. But it's not a silver bullet, and not every project on the planet is going to convert to C into Rust or Java or any of these memory safe languages. So in order to get to the desired spot where we have better memory safety in our development, we need to implement memory safe languages. We need to implement memory safe programming techniques and leverage tools that help find and identify those things so that they can be addressed as part of our defect management and vulnerability management practices.
Yeah, just like your marathon analogy earlier, there's trillions of lines of
Yes.
code we can't rewrite at all. But there are groups like the ISRG, the Internet Security Research Group, the same group behind Let's Encrypt, actually, that are running a whole bunch of strategic efforts to take the most critical software, so stuff sitting at network boundaries, doing the first
Mhm.
deserialization of packets, processing tons and tons of untrusted input, that are written in memory unsafe languages that often have a huge string of CVEs, all related to manual memory management and buffer overflows and things that we just don't need to be dealing with anymore. And then funding rewrites, working with existing maintainers to rewrite the packages in place if possible, or writing new versions where we do need something brand new. So the Linux kernel effort, I think, is a great example there, where Linux kernel has been written in C forever. And
Forever.
memory safe languages have been around for a while, but there hasn't been one that could actually handle the performance and systems level requirements of something like a kernel until very, very recently. Until even just this year, they're still making improvements to the Rust toolchain to make it work in that context. But we have this technology now, and it's time to start using it in the places where you get the biggest bang for your buck in those investments. And so for the Linux kernel, they're not starting inside of the core kernel. They're starting with drivers. Those things sit at the outside. They have the least impact to the rest of it, but they also have the biggest security impact because on your iPhone, on your Android phone, on anything else with those drivers, they're the things processing radio waves and remote exploits that happen just from being near someone. Those drivers are the biggest impact from a security standpoint, and they have the lowest impact. So it's a no-brainer to fund work like that.
Right.
Yeah. And we also can attack the problem by improving and documenting compiler hardening
Mm-hmm.
options. So for like
Yeah.
GCC and glibc and Clang and everything, by getting
C-Lang?
more memory safe checks in there, uh, more memory safe checks into the compiler. Ideally, again, we help head these problems off at the pass.
Right. And as you said correctly, that there is no silver bullet. It does help you address a class of a problem. That's an important element. Last few minutes, I do want to talk about a little bit about Log4j. It'll
Uh-oh.
be not fun to not talk about it. I was reading the CSRB report on it. It talked about once in a generation security event, and in terms of response, it says it was the most intensive cyber security community response in history. CSRB still calls it as an endemic vulnerability. That means the vulnerable instances of Log4j will remain in systems for many years to come. We probably avoided the danger to begin with, but it's probably going to stay until it's completely ruled out. So Log4j was not the first one, definitely not the last one, and the number of vulnerabilities are only increasing. What are some of the things that the industry is doing to be better prepared and better tackle these challenges?
Yeah, you said it's the most intensive security response. I think of that meme from like The Simpsons with Homer and Bart, and he says this is the most intensive security response, and then Homer says, "No, this is the most intensive security response so far." I think you called it. There's no possible way this is going to be the worst one of all time. Right? It was a perfect storm, though, right? It was the most widely used logging library and the most widely used programming language in the world, and it had been sitting there for a decade, so close to a decade, waiting for people to deploy it and get it everywhere. This was on the Mars rover, so it was like an interplanetary software vulnerability, and it also happened to be incredibly easy to exploit with incredibly severe outcomes. So really, a perfect storm in every way. The CSRB report touches on this, but it was a panic. People did everything they could. People worked nights, weekends to get this patched and mitigated because it was being exploited actively all over that weekend. But then people forgot, and I think this is where the endemic part comes in. I saw something like 40% of organizations have accidentally reintroduced it in the next year just by redeploying something that had it in there. And so it's always going to be around until people stop using Java. I don't know if and when that's ever going to happen, right? And so, yeah, there's a lot of challenges with this. I do think SBOM and some of these regulations to actually just pay closer attention to what's in software are going to be a part of it. But I still don't think as an industry we have anything even resembling a solution to stuff like this.
No, and again, our friends at Sonatype, they reported that something like north of 70% of the vulnerabilities that exist within it was like the Maven repository in a given year have a newer version available side by side with the bad broken version, and consumers just aren't pulling the right version, for example. And that's another complication with Log4Shell in that there were two versions of Log4Shell. You had Log4Shell version 2, and then unfortunately a substantial amount of consumers had Log4Shell version 1, which was 5 years out of documented support. The project said we no longer support this 5 years ago, yet the majority of consumers of the Log4j tool were on this version 1.0, 1.x. And so they weren't even potentially exploitable on the version 2 flaw. And again, we have this problem where consumers, there are fixes available. Open source, one thing that it does amazing is as problems are discovered, the community is very reactive. It is able to fix things very quickly. And its downstream has problems, understanding when something is available, when something needs fixed, and then being able to deploy on it. So, as over 30% of systems that were pingable on the internet in 2022 still had vulnerable versions of the Log4j library, and the fix was available the day of public disclosure. So a year later, after the fix has been available, at least 30% of internet exposed systems were still vulnerable.
I think it goes back to the point that not broken, don't fix it. It's like, we are using an older version. We are not gonna take care of it. It's okay. Not our problem. Somebody else. We're gonna just pass an exception in our BDBA tool and keep rolling with it. Gentlemen, I really enjoyed this discussion around open source security. What a fun discussion. I think we covered a really broad range of topic. Have a wonderful weekend, and may the security always be with you.
Thank you.
Thank you. All right.